Okay, so we're going to have a short demonstration about application security, why application security is important, and how a small and relatively insignificant problem with an application, or what we might think is an insignificant problem with an application, can cause some significant heartache, difficulties, and possibly even vulnerabilities, and leave the door open for exploits, which could damage our data, breach our network, cause us damage to our business. So let's, for a moment, imagine that we are IT guys or an IT team within a business environment. The business environment has multiple departments, and one of the departments needs to transfer money or do some processing regularly. So we get a programmer to come along and develop us an application. They write the program for the application, which is going to help us transfer funds between accounts, because our admin guys are spending every day, many hours a day, rekeying manual accounts. The data comes from a third-party system. We know what it's going to look like. We may as well automate the process. This is quite a common thing, and we have seen that in our business all the time. We see many large companies and organizations held together by CSV, or comma-separated file exports, where they export a Excel comma-separated file and they import that in another system. This is really quite common, and it is common to this day. So we write some application specifications up. We say we need to take some data out of one system. It's going to come in a comma-separated file. It's going to have a maximum record length of 285 bytes. And we're going to have 3 fields: an account, an amount, and some notes. And that seems fair enough. Our developer goes away, develops this product, gives it back to us. We run it, and we see that it needs a file. So obviously the developer's doing some error checking there, make sure that we've got the file. And we can run that file through it, and we can see that the input that we gave it has been processed by our processor application here, and it's taken each line, and it's just output each line directly to the screen. All seems very well and good. Our admin guys start using it. They're very happy. They're saving a lot of time every day, and we stop thinking about this application because it's doing what it needs to do. But there might be a problem, and it happens. This happens again, quite a common thing that happens in businesses. You will see people continue to use problematic software, and occasionally what will happen is they'll run this another export file or another import file through it, and it'll crash from time to time. This is annoying, and a lot of people just close these crashes and go, well, this is annoying, it shouldn't have done that. But at application levels, when things are running as apps on your computer, this is quite important, because hackers and malware authors and virus authors, etc., they love crashes, because a crash means the application isn't performing how it's supposed to perform. It hasn't handled some data correctly, which has caused it to go into an unknown state, and it's caused Windows or your Mac to close the program unexpectedly. It means it's crashed. Something has gone wrong. In most situations, people work around this, and it may not entirely, it may be partly due to our fault. We gave the programmer some specifications that said we're going to have a certain file length, and we get this problem file, which occasionally has a very long description because the system we're getting it from didn't know the restriction was there. So the admin guys will, in reality, frequently work around this. They know what the problem is, so they'll delete the offending record, save that file, and continue processing. And everyone seems happy. So we're not doing anything at this point in time to improve the security or improve the stability of this application. We're working around the problems, which is okay as long as we know what those problems are. If we can identify what's gone wrong here, that's fine. This is a difficult thing to do when we don't have access to the source code of this application. We need to trust that the developers used some best practices to make sure that their program is secure and it's going to run reasonably safely. Let's have a look at what the programmer did and why is this crashing, and then let's have a look at why that's important and what it could lead to. This programmer, I'm going to have a really brief look at this because we're not going to go into the code, has made quite a few mistakes in this software. The software starts up, it opens a file here, and then it starts to read the lines of the file, and all it does is reads them and then prints them. It reads them through this function called readLine, and if we have a look at the readLine function up here, we can see that it reads into a string variable. Don't worry too much about what this means, but it reads into this place called local string, and we've said 300 bytes. That makes sense because we've told the programmer that the rules say we should never have a field longer than 285 bytes. So they've left a bit of buffer there. I don't know why, but that's what they've done. then they go and get the lines out of the file. But they've made a typo here. Instead of taking 300 bytes, this command, fgetS, is not a very safe command in C. If you're going to use it, it's fine, but you need to understand all the implications of what could go wrong. So this program has used this without understanding the implications and has manually keyed in this size. So it's going to start reading from the file, and it's going to keep reading and reading and reading. When it runs out of space in this local string here, it's going to keep reading and reading. And what's going to happen? We don't know, because inside the program, all sorts of stuff could be going on as it gets past the end and starts writing in places where it's not supposed to be able to access. What should happen is it should get to 300 here and stop reading and go, no, I'm not taking any more data. It should either return an error or process that in some other way, but it's not. This one is going to keep pulling data in, up to 3 kilobytes of data, and try and shove it into a little box that's only 300 bytes in size. So that's what creates our problem. When we had this problem file, we had one line that was very, very long, and then we had to edit it to make it short enough so it didn't crash. And again, doesn't seem like a big problem, but when we had this crash, we have a situation which is not an uncommon situation. It's called a stack buffer overflow, which means that something that has gone into the space that has been allocated to a program has overflowed into something else. But what does that mean? Well, it means a hacker or a malware author could potentially exploit that. So instead of giving a ordinary file with what you expect, if somehow they can convince an admin staff member to run this wrong file, maybe they email the file, they've sent this email pretending to be another department, and in the middle of this file, they've included this really strange line. So it doesn't look like any of the other lines. It has some weird characters in here, so as we scroll around, we can see that there's some A's with dots and copyright symbols, etc. We might not look at that because we've done this forever. We know that we can just run that file. What happens when we run this exploit file? So this is an exploit that is going to leverage that vulnerability that was in that application from the from what the programmer created. Now remember, all this application is supposed to do is process a file and put stuff out to the screen. It has nothing else in it. There's nothing in this application that should be able to do anything other than write the data to the screen. But when we run this exploit file, it crashes. But instead of just crashing and stopping, it's crashing and opening a web page. That's pretty significant, because if that web page has another exploit on it, or maybe it's got a payload for more information that this vulnerability, this exploit needs, maybe instead of running a web application, if it's running as an administrative user, it could alter the username and password. Once we're at this stage, we're executing quite a complex sequence of commands to open a web page from this one little line here. Everything that happened with opening this site has happened due to this line here. And it's the line that is the actual exploit for the vulnerability that was in the application. So I hope this shows why managing an application and managing the vulnerabilities within an application are important. It means if we have a vulnerable application, we could have a situation where someone could attack our systems. This is even more of a problem if it's a well-known application, because vulnerabilities and exploits are quite often well-published and well-documented, so everyone knows what they are, especially if you're in the security world. And it's also a problem if we are developing our own software, because when we developed our rules, we said nothing about application programming standards or minimum quality standards or what we expected from the programmer. So we didn't know how they were writing this software. This is something we all need to take into account. It's something we all need to think about. So if we're managing applications, if we're managing security, if we're trying to break into somewhere, we need to think about application security, application vulnerabilities, and what exploits could be applied. This is important for us as security experts who are trying to protect a network, because we need to know the full life cycle of our applications that we're running. We might have older versions of Internet Explorer or older versions of Flash or even this data importer app. If we don't know that we're running them, we don't know what versions there are, and we don't have a good patch process for them, these applications will get out of date, vulnerabilities will be discovered, and exploits could get written. The problem here is that as these exploits and vulnerabilities get out into the public, or people learn what's going on inside an organization, they can start to craft targeted attacks which can breach our entire enterprise. As attackers, if we're trying to get into a network, if we're doing some penetration testing, We want to know what application versions they're running, and we want to go and search to see if there are any known exploits and any ways of getting in to their organization through a faulty application.